Hello, I am Shruti Nagpal, a PhD student at IIIT Delhi, India, and in this presentation, I will be talking about our research Attribute Aware Filter Drop for Bias Invariant Classification. The use and development of machine learning has become prevalent in today's times. We can observe machine learning based systems all around us. However, some recent studies have highlighted a new challenge of bias and fairness in machine learning based systems. A well talked about study conducted by a group of researchers at MIT highlighted the difference in accuracy for different subgroups across gender and ethnicity when performing gender prediction using commercial systems. This demonstrated how certain subgroups are more vulnerable as compared to others when using automated systems. If we look closely at the image on the right side of the screen, it comprises of two brides belonging to different cultures. However, a study conducted suggested that most algorithms recognize only the image on the left as a bride, suggesting biased behavior. One of the most known datasets in the machine learning community is ImageNet, and research on the geographical distribution of the images demonstrates that a majority of them belong to 2 to 3 countries only. Such observations and revelations demand the need to develop bias invariant models which output unbiased outcomes even with skewed training data. Thus, in this research, we present a bias invariant learning technique termed as attribute aware filter drop. The figure on the screen showcases the setup. The model is a multitask network which comprises of a primary task and a bias covariate task. In our case study, the primary task is that of gender prediction from a face image. The bias covariate corresponds to the protected attribute against which the model bias is studied. In our case, the bias covariate is ethnicity. The model is a standard convolutional neural network comprising of convolution and pooling layers, followed by global average pooling to get the dense feature layer. Filter drop is applied to this penultimate layer, the one obtained after global average pooling. So, the features obtained after global average pooling are say y. On applying filter drop, we obtain y drop. Y drop is computed by multiplying the feature y with a binary mask matrix M, which defines the active filters and the filters to be dropped. The filters to be dropped are selected based on the bias covariate task. We identify the filters which contribute the most for the task of classifying the bias covariate with the hypothesis that these filters are encoding the bias covariate. We drop these filters for the primary task in order to perform bias invariant classification irrespective of the data distribution. Thus, the feature y is used for performing classification of the bias covariate, that is, the secondary task in the model, while y drop, which is the masked out feature, is used to perform the primary task, and the model is optimized accordingly. At the time of testing, we use the final M matrix obtained after training. The M matrix is a binary matrix used to identify the active filters, which are used to perform the primary task. The proposed filter drop is evaluated for the task of gender prediction from face images while eliminating the effect of ethnicity. We use two datasets, UTKFace and FairFace in our study, and 3 ethnicities. The experiments are performed in 2 setups with 2 ethnicities in each setup. Further, the proposed approach is evaluated on 2 protocols. One using balanced training data for the 2 ethnicities and the other with skewed training data. Under skewed training data, the training set consists of 90% of the images belonging to one ethnicity and the remaining 10% to the other ethnicity. Looking at the results for the first protocol with equal training data, results are reported using the proposed filter drop technique and compared with the traditional method of using all the learned filters at the time of testing. The proposed filter drop obtains similar accuracies across different ethnic groups. Now, when we look at the results of the second protocol, that is for skewed training data, we observe that the results obtained by the proposed approach are near about similar for the two ethnicities despite the training data being heavily skewed with a ratio of 9:1. The difference in accuracies between the ethnic groups reported in the last column of the table, that is EA minus EB, is considerably reduced using the proposed method. For example, on the UTKFace dataset, on both the setups, the proposed technique achieves less than 1% variation across the different ethnic groups. This demonstrates the effectiveness of the proposed approach. Upon further analysis, we observe similar behavior in terms of performance, in terms of the accuracy across the different gender groups. We also look at some misclassifications and observe pose, illumination, and blur to be a major challenge. As demonstrated, this research achieves lower variations across subgroups for gender classification under the bias covariate of ethnicity. The proposed technique can also be formulated for multi-class problems in the future and can be extended to learn bias invariant features without using the bias covariate label. Further, bias mitigation is an important challenge which needs dedicated attention of the research community as it has several fairness implications associated with it when automated systems are deployed in sensitive scenarios. Thank you. To know more about our work, please read our paper. You can contact any of the authors in case you want to discuss more on this particular research. Please visit our website to know more about our work.